let me first thank Jörg Worlitschek, Professor Jörg Worlitschek, for giving this talk. He is leading the Competence Center for Thermal Energy Systems and Process Technology at HSLU. And well, this has been a big success, and thermal energy storage, a very large group which is widely known. And it is very important that this group is also present in DeCarbCH, because obviously thermal energy storage plays a very important role when we think about thermal grids, but also about industry. So there is a lot of work in front of us, and we are very excited about hearing your thoughts, Jörg. The floor is yours.
Thank you, Martin. Thank you very much. Yes, the title of my talk is Long-Term Thermal Energy Storages Opportunities for Switzerland, meant in a way that I would mainly like to show what's around and what thoughts we have, and with that, hopefully trigger as well the activities within DeCarbCH to look more into, or to look into this direction in depth. I am starting with a slide which I tend to start now every presentation in, and my apologies. I know we all have the same motivation, but nevertheless, I would like to really make it clear. So climate change is real. And what you see here is from a paper from us from 2019, and there is a study about basically each square kilometer in Switzerland, and then taking from the ETH climate change models, all the different climate change models that are around at the moment, and then taking the trends, or taking all of them and calculating the heating and cooling demand in each square kilometer, and then integrating it over whole Switzerland back again. And this here is quantified by heating degree days and cooling degree days, which is one of the typical ways to quantify heating and cooling demand. And here on the right-hand side, you can see the trends here. And if you look at the quantification of that, then the main trend here gives in heating degree days by the end of the century a minus of around 40%, and by the cooling degree days a plus of around 1,200%. So if you imagine Zurich, or where we are living now, this is more or less Tuscany in Italy, and if you're going there for vacation, you know more or less how it is there, and that's, well, by all certain uncertainties, of course, to be considered, that's more or less where we will be by the end of the century. I'm showing that for two reasons. Number one is that we really see that one now already should take that into account, what our heating and cooling demands are, and by far, so today we don't do that when we plan buildings, although they typically range already quite ahead. And the other thing is, and that's about thermal energy storage, or long-term thermal energy storage, one can really see that the chances of closing the seasonal gap is higher with that, because we have lower heating demand, higher cooling demand. So this means the gap is smaller on the heating demand, and we have a chance to use both sides, and then use these effects more than we do that today. So that's as well one good hint, or one good way of seeing these possibilities. Of course, to make the story round here around these thoughts, well, of course, this is only when we think then of energy demand, this is only the very first part of the story. So here, this is really what we need in just from the climate perspective. Of course, this can change. But then, of course, there is a whole series of considerations which then lead to the real energy that we consume at the end. No? It's about the choice of our quality and quantity. Will we really want to fulfill the cooling demand, which we don't fulfill at the moment? But if it's increasing, will we fully use that? And then, well, how is population changing and all these thoughts? And then at the end, which technologies do we choose? And that's mainly now as well part of our DeCarbCH, no? What whole scenarios we have, but then as well, what technologies do we use to decrease the energy demand at the very end? Good. So as Martin already said, we are the Competence Center Thermal Energy Storage and at HSLU, and I'm happy to present here maybe just one word about our Competence Center. So we care about assessment of storages, so techno-economic assessments, then energy data and models and thermal energy system models and data science to be combined. We care about different heat and cold storages, and with a focus on as well on long-term storage. And then as an add-on, due to our competences, we care as well about processes and products which really need high precision in temperature stability. So in general, one can say when we look at at the different models and at the scenarios, one can see then the different frequency challenges, minutes, daily, and then seasonal, and minutes meaning, well, there one could even go deeper, no, in milliseconds. If we look at the electrical grid, if we look at heating and cooling, there we are probably on the process side. If we look at processes, we are still in a minutes region. So now for today, I would like to stay here with seasonal, and at the moment we are putting together a group of people over a few institutions. We are trying to put a bit together some arguments or some evidence of long-term thermal energy storage. And just to show a few numbers in this context, well, first of all, if we look at the energy perspective, the estimated electricity lack in 2050, it's there around 9 terawatt hours, and the estimated electricity demand for the heat pumps, for bigger heat pumps in 2050, is around 9 terawatt hours. So just to show, I mean, a bit the size ranges here. And then, thanks to Gianfranco, a few numbers from latest simulations out of the energy system models. So there, if one looks at a CO2 neutral scenario, one ends up with possible scenarios of heat pumps, so bigger heat pumps in thermal grids with a demand with a thermal energy energy of 6 to 8 terawatt hours per year, and possibilities for long-term thermal energy storages in these grids around 2 to 3 terawatt hours. And then going back into the electrical demand, that's of course less than we are around 1 terawatt hours, just to get a bit a feeling of it. And then we would be in the range of 10 to 20% reduction of this winter gap, electricity winter gap. Of course, well, looking at thermal energy storages, one could say that I personally think that the potentials are higher even, because we maybe have not considered everything in all models and everywhere, but yeah, that's a bit about the range. In general, when we look at thermal energy storage, and that's true as well for long term, then we have three different ways: sensible, latent, and thermochemical. Sensible, heating something up, the ground, water, etc., up and down, and with that storing. Latent, going through a phase change, so like ice storages, or then other materials which melt and crystallize, or which go through other phase changes, and from liquid to vapor, for example, and then thermochemical. And they're on the one hand absorption and adsorption processes and chemical reactions. So that's the three types. And now looking at the possibilities, when we look at long term here, then one must say that, of course, it's a matter of economics. So they're sensible, so meaning water and ground, of course, has a lot of advantages. On the other right-hand side, thermochemical, also not that far into development yet, would have the big chance that we have no losses, because we really store in the chemical reaction, and then could go over long term much better. So in my perspective, it is for sure worth going further in thermochemical developments, in thermochemical research, with different systems. One sees now groups popping up where things are really getting evident. For example, University of Eindhoven in the Netherlands, for example, where there are big achievements there in this direction. At the moment, TU Munich is working as well on good systems. And then as well, the work which has been done at EMPA and in Rapperswil on NaOH, all these kind of things are important to look at in a longer range for sure. And then we have latent storage. There is one of our focus areas as well in our competence center. So these might be combinations, bringing in latent into the whole systems, which might make sure to stabilize temperatures and to increase storage densities. So just to give a quick overview of possibilities, for those of you who are not that familiar with the possibilities. So if we have an overview of long-term thermal energy storage, well, now I'm focusing more on storages for districts, because that's, I think, what we want to look more in DeCarbCH, because that's where we have the bigger challenge. So if we look at different possibilities, we have more or less four types: container heat storages with water, pit heat storages with water, then borehole fields and aquifers. Showing here some examples. So on container heat storage, for example, a smaller grid in Munich, where you see at the end, it looks like that. In Swiss German, one would say an Überbauung size of grid around. And one could see these kind of solutions, where one could really think that this goes in a direction where in Switzerland, where from a social and political point of view in Switzerland, one could have chances for similar solutions. As well, something which is under development in the Netherlands, there is a company called EcoWatt. They propose a system which is really underground. This as well could be in a Swiss context, could be a way forward, and where one could look to work together with them. So they developed a special way to build these kind of storages. Then pit heat storages. Well, when talking about these topics, one always looks at Denmark, because Denmark is really far ahead when one looks at these systems. And so here is one example which is very often shown. It's from Vojens in Denmark, 200,000 cubic meter. Here it's still under construction, but this is running now already for many years. So this is covered then here. The technology is a lot about the cover, which is on top here as well at the end. And here, we always tend to say, well, this is not possible for Switzerland, and this will never make its way. I think we shouldn't make it too easy for us. I think we should look at under which circumstances, where it could make sense, and where we could see these possibilities, and what would be the political and social measures to really drive these things, instead of just, I mean, I tend to say, well, that's difficult for Switzerland because of land use, etc. But maybe we find ways to drive that. If we look at borehole storage, well, here we have examples in Switzerland, like, for example, DeCarbCH Henkelberg, which is well known, where we have such a system installed, and there are a couple of other systems which are installed all over Switzerland. And then, well, we have aquifer systems which use then in the ground. So geothermal Possbilities. A well-known example is, for example, in Germany under the Berlin Reichstag, where there are different layers which are used. In Switzerland, well, it's a bit a matter of definition, what we define how. There are on aquifers, there's a lot of activity to looking into things in the Geneva area about possibilities. There is as well the planned borehole geothermal storage, which goes into that direction. It's planned in Bern, at the Forsthaus in Bern, where we will work together as well within DeCarbCH, and here we have deeper drillings down to 500 meters, and then we use the different layers here to then the different layers are used to store the thermal energy. For buildings, there are different possibilities. While we know the Yeni tank, but there are as well highly newer vacuum type of insulations which allow to bring it into the ground. There are possibilities of insulating enclosures. There are possibilities then as well for ground heat exchangers, and of course as well on the thermochemical side, as I mentioned before. On ice storage, this is something which one can think for districts and for buildings. There are systems as well for bigger districts. If you look at cooling and heating demand on both sides, and looking longer ahead into what I've shown before, into the more equaling out of heating and cooling demand, then ice storages might become interesting in the future. Something about economic aspects. If we look at long-term storage, then one challenge is for sure that we don't use the storage as normally one would say, charge and discharge as much as possible. We have less cycles. We might have, if we go to the extreme, we have a bit above 1 if we are really seasonal, but maybe we should go ahead for more the 80-20, then we might be in a region of a few cycles per year. And then still the price is really something which is very, very important. And here one sees many different systems which have been installed, and one can really see that one can summarize by saying size matters. So the bigger we go, the easier it becomes to go economically low. This, of course, is a bit in contrary if we say in Switzerland we would like to stay with, let's say, medium size thermal energy storages to be on a political and social perspective more reasonable there, then we really have the challenge of bringing the prices down in this region. And if we go to buildings, well, then we see that the prices are really higher. So there we should really think of then bringing these numbers as well now. If we look at our research questions that we have set ourselves for long-term thermal energy storage, it's that what I just said. It's really thinking about how can we reduce the cost, and then as well how can we reduce the visual effects, the impacts. So here it's shown for a building, but I think it's even more true if we think of districts and more. And then having possibilities for storing in the ground. So how can we do other boreholes? For example, we have one project where it's about different drilling possibilities today, where one does not have to drill all straight down, but one could drill as well under already covered areas and under buildings. Then it's the whole story about covering the models and then making sure that these models make its way into the system models, into the energy system models for the different scenarios. Today one can still see, and thanks to Gianfranco, I mean, you kind of are almost an exception out of the different models that so far in the all over national views we still are lacking that. And well, Martin, we will see what's coming out of our SNF project, which is about to finish, that one can see more on a national level what the effects are. But in general, we have to make sure that these possibilities make their way more into then future energy perspectives. And then from our view, looking as well into combinations with latent thermal energy storage. And then last but not least, how can we make sure that that this makes its way into society? And we are happy that now we could start one project with social scientists and another project, long-term project with political scientists, to see what are the mechanisms to drive these kind of bigger installations, and to make sure that what measures and what triggers we have to change here the possibilities that these big installations and big infrastructures make their way into Switzerland. Maybe only showing a few things which are important. While at the end, small or big storages does not make a difference. Control and stratification is something which is very important. So here, seeing results from our models and optimizations, one can see that one has lever arms of up to 40% reduction of storage volume when one goes through other control mechanisms, which then as well take care a lot about the stratification in thermal storages. So that's not to be underestimated. On the other hand, what we see as possibilities is that we have a lot of enclosures in Switzerland, naming bunkers, naming other possibilities. So if we want to drive down the costs, we could think of going into these directions here as well. Together with Swisspor, we have developed and are still developing possibilities for enabling underground storages, which are just coming out of enclosures by the means of new insulation materials. there is a pilot plant already working and ongoing. And now, when one looks at combining with latent materials, of course, it depends a lot on the delta T. So we have here a map of all different phase change materials, latent materials, so where we would use heating and melting and crystallization. Here you see the heat capacity, here you see the melting temperatures, and if we want to use that, then it depends, of course, a lot on the delta T where we want to store. And well, if we look at the district networks, thermal grids today, they typically run at high temperatures, so we have a big delta T that can be used, but trends are going more and more towards smaller delta T's that are used, and with that, the sensible storage is becoming bigger and bigger. So here we really see the chance of bringing in at least partially latent components to reduce the size. So one sees here, if we go over a big range, then we are at a certain level where phase change materials make sense. If delta T's reduce, then there is already much more potential for bringing in melting and crystallization aspects into the storage. So these could be done by combining then sensible and latent, and this could have two effects. On the one hand, increasing the storage density, but as well on the other hand, to be able to go into other shapes where then stratification could be ensured by bringing in latent components which ensure then certain temperature ranges. This can not only be thought small, this could be thought in bigger contexts, where in a Swiss context in particular, we could think of using underground enclosures which are around, but using, of course, as well combinations with boreholes and other technologies, and then bringing in maybe these kind of stratification insurances, I could call it, using latent materials. Yes, that was a bit a view on different possibilities and different views into long-term thermal energy storage. From my point of view, the big opportunities are that we bring them into the models and into the detailed views, that we look further for more compact possibilities which could fit for Switzerland, and see to work very closely together with social and political scientists to drive this and to understand where the lever arms are. Thank you very much. And yes, that was it. There would have been just 2 hints if someone wants to go further. We have on Friday 28th, now in a bit less than 2 weeks, we have our 9th Swiss Symposium Thermal Energy Storage. So if you would like to go deeper, then feel free to register. It's fully online. And if you really want to go deeper, then in summer we have a PhD summer school on latent materials, and you could go further. So thanks to the team. Thanks to you for listening.
Thank you very much, Jörg, for this very nice overview.